All right, last video of Unit 1 of Semester B on Algebra 2. Yeah! All right, in this one, we're going to be actually graphing the rational functions by hand. So there's going to be something that we use called a sign chart. At least Apex uses it. I don't always use it in the classroom, but I'm going to show you what they're talking about, and I'll show you a little bit what I'm talking about as well. So we use something called a sign chart to help us determine whether the function is positive and negative. It's pretty easy. But to fill out the sign chart, we'll need to use test numbers, so they'll ask you questions about that. But it involves the zeros and the asymptotes, the vertical asymptotes. They don't talk too much about the horizontal asymptotes. You guys will get that more in pre-cal as well. So first thing, we need to find the zeros and the vertical asymptotes. That's the most important thing to use when we're actually graphing these things by hand. So example 1. We're only going to do 4 of them, so it'll take a decent amount of time. Graph the rational functions. And don't forget, you guys are able to use Desmos, so I mean, you can check your answers, you can see what it looks like. It should be pretty easy for you guys to do pretty well, especially since you have a calculator and you have Desmos. You can type it in, you can do all this without hand. That's how the course goes. I'm not going to restrict you guys from doing that. All right, so graph the rational functions. 1 over x plus 3. So for the zeros, don't forget a zero is a solution. A solution is when our function equals 0. That's why it's called a zero. So if we want to find the zeros, I can take my function, set it equal to 0. And remember, we did this in a previous lesson. So I would have had to multiply by x plus 3 on both sides, so I would get 0 equals 1. Well, 0 doesn't equal 1, so there would be no zeros for this one. So there's no zeros. Now for the vertical asymptote, we just did this in the last video. Remember, it's when the denominator cannot be equal to 0. So in this case, I cannot have negative 3. So now in my sign chart, what I worry about is my zeros and my vertical asymptote. I think I said tart. All right. So I create a line graph. And the thing that I care about is my vertical asymptote at negative 3. And I even label it vertical asymptote, so I know what that is. And then on my graph, what else I can do is at negative 3, I know that I'm going to have a vertical asymptote. So I'm going to go ahead and draw that there. So now I just need to figure out where it's positive, where it's negative. It's never 0, so that tells me I have a horizontal asymptote at 0 as well. All right, so that hasn't changed. So now, the test values, the test numbers, what they mean is pick something to the left of negative 3, say we do like negative 10. If I substitute x equals negative 10 and I do 1 over negative 10 plus 3, the value that comes out is 1 over negative 7. The thing that I care about that number is that number is negative. Minus VE means negative. Negative. See, it takes too long. That's why I write minus VE. Negative means negative, or minus means negative. So what that tells me is that I will be all down here getting closer to my asymptotes in both directions. Now on the right-hand side of negative 3, say I choose 0. So if I put in 1 over 0 plus 3, the thing that I care about is that's 1 over positive 3, so it comes out positive. So plus VE means positive. So this graph will be going all right there. All right, so, and also what I look at, I figure out what my zeros are, and then I graph what I can, my y-intercept, but you'll learn more of that in pre-cal as well. But what I look at is this is the point 0, 1/3. This was the point negative 10, negative 1/7. So I had 0, 1/3, and I had negative 10, negative 1/7. Since our graph does not cross asymptotes, except in rare equations when it crosses the horizontal asymptote. Whoa, that's crazy. You won't see that yet. I know that it's going to be going closer to the asymptotes in both directions on this side, and since that point is there, it has to be going closer to the asymptote out here, and going closer to the asymptote in that direction as well. So I know I'm not going to cross it. So now, the other thing, if they ask you for the domain, they're going to start using set notation a little bit. So this is x such that, bar means such that, x is not equal to our vertical asymptote here, which is -3. That's how they will start writing the domain. The most important thing is that part right there, that x cannot be -3. All right, moving on. So with part B here, we're actually going to have some stuff. So remember the zeros and the vertical asymptotes. That's what I care about. The zeros you can actually find by setting the numerator equal to 0 and solving. So x equals -1. And my vertical asymptotes, I'll have 2 and -4. All right, so now those are the things I need to put on my line. Also, what I'm going to go ahead and do, since I have a vertical asymptote at 2, I'm going to go ahead and put it at 2 and -4. Alrighty. Oh no, I'm starting to get a line in here. It's becoming too late in the day. Go away, shade, or sun. Oh no, now it's just getting super dark. Man! How about that? We'll do that. That looks better, right? Yeah, that looks better. Okay, make this video fast. On my sign chart, I need to put all of these values. So I have a 0 at -1. Right? That's a 0, which also means I will be crossing the x-axis at -1. It's going to be hitting that point right there. So something crazy may happen here. And then I also have a vertical asymptote at -4. That's a vertical asymptote. I have a vertical asymptote at 2. That's also a vertical asymptote. So now I need to check values around those. So if I choose, say, -10 again, if I do -10 plus 1 over -10 minus 2 and -10 plus 4. So this would be -9 over -12 times -6 would be a +96. So the biggest thing I care about is this is a negative value over here. So these are negative right there. Now if I choose something between -4 and -1, say I choose -2. If I put in -2, that'd be negative on top. That's negative, that's positive. So negative divided by a negative would be a positive. See, I choose something between -1 and 2. Easiest number is 0. So I have 1 over negative times a positive, which would be a positive divided by a negative, which would be a negative value. And then I choose something bigger than 2. Say I choose 10. 10 plus 1 is positive. 10 minus 2 is positive. 10 plus 4 is positive. So this is a positive interval right there. So what that tells me, on the left-hand side of -4, it's all negative. So on this side of my vertical asymptote, I must be down here. So they're all negative y values. Right? Between -4 and -1, it's all positive values. So since these are all positive, this must be going something like that. Then from -1 to 2, they're all negative values. So this side, it's really weird, but it must be doing something like that. And then from -2 on, it's all positive values. So this part must be up here doing something like that, since all the y values are positive. They're all above 0. That's essentially what's going on here. Again, you guys can type these in Desmos as you guys go to double check your answers. And again, the domain, they're going to start writing it kind of weird, but we cannot have x such that x would have been equal to 2 and -4. Right, so again, that's the part that you're really looking for. X could not be 2 and x could not be -4. All right, let's do another. So same sort of idea. Find your zeros, find your vertical asymptotes, and then graph them and test them around them. So zeros. Again, I have x plus 1. So x plus 1 equals 0. So x is -1. So I'm going to cross the x-axis at -1. I'll go ahead and put that on my graph. For the vertical asymptotes, I cannot be 1 and I cannot be 2, -2. So I have -2 and I have 1. All right, put those on a line. So I have -2, which is a vertical asymptote. I have -1, which is a 0. And I have 1, which is a vertical asymptote. So now if I check around these values, say I choose -10. -10 plus 1 would be a negative number. This would be a negative, and this would be a negative. So negative times a negative down here is a positive. Negative divided by a positive would give us a negative interval. So I know this part of the graph is down below in the negative y values. All right. So now between -2 and -1, it's kind of a pain, but we could do like -1.5, because that would create negative on top, right? -1.5 plus 1 will be a negative on top over negative times a positive. So a negative on bottom, negative divided by a negative is a positive. So I know I'm going to be going above 0 on the y-axis. And then between -1 and 1 would be like 0. So if I put in 0, that's a positive over 0. -1 times 2 is a negative, so that will be a negative interval. So I'm going to get closer to the asymptote in this direction. And then the last part, bigger than 1, say I choose 10 or something, that's going to be a positive over a positive times a positive. So it will all be a positive interval. So I'm going to be above the y-axis and getting closer to my asymptotes the entire time. Cool. All right, got one more, and then we're done. It's trash now. At least I don't need it. You guys probably still want it. All right, last one. This one looks kind of crazy at first, right? There's a lot of stuff on here. But check it out. Something happens in this one. We have a common factor that we learned we can divide out. So here's the thing. When we have a common factor that we can divide out, yeah, we divide it out, but what it creates is something called a hole. Apex doesn't get into it too much, and I'm not going to either. But what a hole is it's a value that is still in our function, but we cannot be equal to it. So let me create one with a hole real quick and show you kind of what it looks like. Oops. All right, so nice function, yeah. But notice how we have a common factor of x plus 1. So what that does is when x is -1, it's not possible to be -1 because of this part right here. So what's going to happen at -1, it's not actually going to give me a value. So notice it flipped right there, and it's actually showing me a hole too. See how it's showing closed dot, closed dot, closed dot, and then it shows an open dot right there. That's called a hole, or a removable discontinuity, which you'll learn more about in pre-cal as well. But it's not actually defined at that value. It's just something that, since we can simplify, it's like a point was just like plucked out of our equation because we simplified that factor. So that's what it is. That's why it's called a hole, because it's just a non-existent thing, but it gets really close to it, around it, from both sides. So as we graph, we'll keep that in mind. But again, you guys are going to get way more in depth than that in pre-cal, but that's what it is. I'm just introducing it to you guys. So I'll write that off to the side. We have a hole at -4, but I know it's just going to go around that value, so I'm not going to worry too much. Wherever it ends up, it'll end up. So now for the zeros, I only have x minus 1 up there now because this factor has gone away. So I have x minus 1, which means I have a 0 when x equals 1. So at x equals 1, I have a 0. I'm hitting the x-axis down there. All right, I'm going to zoom out a little bit here so you can probably still read all of this. You can full screen YouTube too. So full screen YouTube, and it'll come up easier. All right, so vertical asymptote. Now it's going to be at x equals 4 and x equals -7. So I'm going to go ahead and put those on the graph. So -7 and x equals 4. All right, so there's all the information without looking at our line test. So now, using those values, I have -7 which is a vertical asymptote. I have 1, which is a 0, and I have 4, which is also a vertical asymptote. I'm going to worry about that hole whenever we figure out what's happening between here. So say I choose negative 10. If I put in negative 10 into my function, negative 10 minus 1 will create a negative value on top, and then this will be negative, so negative times a negative 10 plus 7 is a negative. So a negative times a negative is a positive, so we have a negative divided by a positive, which will create a negative interval overall. So I know I'm below the y-axis, going something like that right there the entire time. All right. The next thing, between negative 7 and negative 1, or sorry, positive 1, say I choose 0 because that's easy, because 0 minus 1 is a negative, over 0 minus 4 is a negative, and 0 plus 1 is a positive. So a negative divided by a negative is a positive interval. So it's going to be positive the entire time. So remember now, at negative 4, right, we have a hole at negative 4. What that's going to do, since I know I'm going positive the whole time, I'm just going to kind of guesstimate where about this is. You can actually plug it in and find the y value as well if you wanted to, but I'm just rough drawing it. All right, so maybe something like that. All right, notice at negative 4, I just put an open circle to recognize that we have a hole there. All right, now between 1 and 4, say I choose 2 or something. 2 minus 1 is a positive number. 2 minus 4 is negative. And 2 plus 7 is positive. So I have a positive divided by a negative, which will be negative. So it's going to go all below the y-axis there. And then bigger than 4, say like 10. 10 minus 1 is a positive, over 10 minus 4 is a positive, and 10 plus 7 is also a positive, so that will be a positive interval. So I know I'm all above the x-axis there. So that would be essentially our graph. And then for the domain on this one, I would have x such that x cannot be, so now x still cannot be that negative 4 at the hole, so I have negative 7, negative 4, and 4. All of those values are still no good because they would all make my denominator 0 in the original function. Still use that x plus 4 for your domain because it cannot be that negative 4. All right, sorry this was so long. Hopefully it was super explanatory for you guys and it made sense. Again, whatever doesn't make sense, please just email me, let me know. We can always set up a live one-on-one chat. Bring on your questions. All right, look forward to talking to you guys. Bye.